We are going to learn Chapter 2, Relations and Functions. So before learning the definitions of relations and functions, we have to learn about Cartesian product of sets. Cartesian product of sets can be called as cross product also. For example, let us take set P as 1, 2, 3 and set Q as A, B. So the Cartesian product of these two sets is denoted as P cross Q. And how do we write the Cartesian product of these two sets? We have to write the elements of P cross Q as ordered pairs. And the first element should be taken from the first set P and the second element should be taken from the second set Q. So 1A, 1B, 2A, 2B, 3A and 3B. So these are the elements of P cross Q. If I show it using arrow diagram, this is called arrow diagram. This is set P, this is set Q. So 1 is related to A. 1, A, 1, B, 2, A, 2, B, 3, A, 3, B. So we have written all possible combinations of ordered pairs, taking the first element from P set and taking the second element from Q set. Let us now write Q cross P. So this is also set of all ordered pairs, but the first element should be taken from set Q and the second element should be taken from set P. So in that case, I will take this figure. I should have Q set first and then P. Q's elements are A and B. P's elements are 1, 2 and 3. So I have to write A1, A2, A3. I'm writing ordered pairs. And then B1, B2, B3. If you notice, P cross Q and Q cross P, they have the same number of elements. Number of elements of P cross Q and number of elements of Q cross P are same. They have 6 elements each. But the elements are not the same. 1, A and A, 1 are not the same elements. That's why we call them as ordered pairs. If you change the order of these elements, that represents a different element. 1A and A1 are different elements. Why do we call this as Cartesian product? A Cartesian plane, we have x-axis, y-axis and we plot the points. So in Cartesian plane, the point 2, 5 and 5, 2 are two different points. Similarly, here also in Cartesian product, 1, A and A, 1 are different elements. That's why we call them as ordered pairs. Now we will learn the definition of the Cartesian product. See page number 31, definition 1 in your textbook. Given two non-empty sets P and Q. So P and Q, we are taking them as non-empty sets. So the Cartesian product P cross Q is the set of all ordered pairs of elements P, Q such that P is from the first set capital P and Q is from the second set capital Q. We denote the sets by capital letters and the elements of those sets by small letters. And this has been written in set builder form. This is the definition of Cartesian product in set builder form. Now let us take the same example, 1, 2, 3 and Q as A, B. I showed this P cross Q using arrow diagram. or you may write it like taking x-axis and y-axis. That's why we call this as Cartesian product, like Cartesian plane. So we have, like, on the x-axis we take the first elements, and on the y-axis we take the second elements. Like a grid we form. So these are the ordered pairs which we are going to write. So the ordered pairs, this ordered pair will be 1 comma a, and this will be 1 comma b, this is 2 comma a, and this is 2 comma b, this is 3 comma a and 3 comma b. These are the elements of p cross q. If you have to write q cross p, we will take AB along the horizontal axis and 1, 2, 3 along the vertical axis. Therefore, these are the elements of Q cross P. This is A comma 1, A comma 2, A comma 3, B comma 1, B comma 2 and B comma 3. So the number of elements of P cross Q and Q cross P will be the same, but the elements are not the same unless the sets are equal. See the remarks given in the textbook on page number 31. The first one, two ordered pairs are equal if and only if the corresponding first elements are equal and the second elements are also equal. For example, if I take an ordered pair x comma y, and if I say that it is equal to 2 comma 5, then the first element should be the same and the second element should be the same. Therefore, we can say that x must be 2 and y must be 5. Then remark 2. If there are p elements in set A, so number of elements in set A is p, number of elements of set B is q, say. Then how many elements will be there in the Cartesian product of A and B, p into q? Number of elements of B cross A is also q into p, which is equal to p into q. Then the third remark, if A and B are non-empty sets, what happens if one of the sets is empty set? For example, A is an empty set, say, and B is A comma B. So A cross B will be an empty set. If one of the sets is an empty set, then Cartesian product is also an empty set. What happens if one of the sets is infinite set? If A is an infinite set or B is an infinite set. For example, let us consider A as an infinite set and B as A comma B. Let me take A as 1, 2, 3, etc. natural number set. A cross B will be 1A, 1B, 2A, 2B, etc. That becomes an infinite set when they are non-empty sets. If one of the sets is an infinite set, then Cartesian product is also an infinite set. Next, fourth remark, we are going to write A cross A cross A, Cartesian product of three sets. The three sets may be different, or here they have taken the same sets. So the definition is we have to write ordered triplets A, B, C, where all the three elements are taken from set A. Here this A, B, C is called an ordered triplet. For example, let us take A set as -1, 0. Let us first write A cross A, Cartesian product of A and A. So minus 1, minus 1, minus 1, 0, 0, comma minus 1 and 0, comma 0. A has 2 elements, so 2 2s are 4 elements will be there in A cross A. Now we will write A cross A cross A. We did A cross A first. In A cross A, we have minus 1, minus 1, minus 1, 0, 0, minus 1. We have ordered pairs, 4 ordered pairs are there. And A has 2 elements. Let us write the elements of A cross A cross A. So the first one will be minus 1, minus 1, minus 1. And then minus 1, minus 1, 0. Now let us write with the second element. Minus 1, 0, minus 1, minus 1, 0, 0. And then with the third element. 0, minus 1, minus 1, 0, minus 1 and 0. Then with the fourth element. 0, 0, minus 1, 0, 0, 0. So totally we have 8 elements. Number of elements of A is 2. So number of elements of A cross A cross A will be 2 into 2 into 2, which is 8. Now we will start exercise 2.1. First question. If x by 3 plus 1 y minus 2 by 3 is equal to 5 by 3, 1 by 3. Find the values of x and y. We know the definition. If two ordered pairs are equal, their first element should be equal and their second element should be equal. So equate the corresponding elements. X by 3 plus 1 must be 5 by 3, from which we can find the value of x. 5 by 3 minus 1, which is 2 by 3. So x is 2. Similarly, equate the second elements. Y minus 2 by 3 is 1 by 3. Y equals 1 by 3 plus 2 by 3. 3 by 3 is 1. Y value is 1. So we found x and y. Now question 2. If the set A has 3 elements, n of A is 3, and set B is 3, 4 and 5. So n of B is also 3. Find the number of elements of A cross B, which is equal to 3 into 3, 9. So in Cartesian product of A and B, we will have 9 elements. Question 3. G set is given as 7, 8 and H is 5, 4 and 2. Find G cross H. So we have to write the ordered pairs. Go in orderly manner. So 7, 5, 7, 4, 7, 2, then 8, 5, 8, 4, 8, 2. This is G cross H, and we have to find H cross G. We have to write the elements of H first here. So 5, 7, 4, 7, 2, 7, and then 5, 8, 4, 8 and 2, 8. They have the same number of elements, but the elements are not the same. Question 4. State whether each of the following statements are true or false. If the statement is false, rewrite the given statement correctly. First subdivision, P set is given as M, N and Q set is N, M. P cross Q is given as Mn and Nm. We know that P has two elements, Q has two elements, so P cross Q will have 2 2s are 4 elements. But here only 2 elements are given, therefore this is false. In case it is false, we have to rewrite the correct statement. So we will write the correct P cross Q set. So the Cartesian product of P and Q should have 4 elements, Mn, Mm, Nn and Nm. This is the correct answer. Second subdivision, if A and B are non-empty sets, A cross B is a non-empty set of ordered pairs x, y such that x belongs to A and y belongs to B. It is true. That is the definition of the Cartesian product of two sets. Ordered pairs x, y such that x is taken from set A and y is taken from set B. This is the definition. So it is true. Now the third subdivision, set A is given as 1, 2 and set B is 3, 4. Then A cross B intersection C we have to find. Let us write B intersection 5. B intersection 5 is 5, null set. Now A cross B intersection 5 we have to write. If one of the sets is a null set, we know that the Cartesian product is also a null set. Therefore, the given statement is true. Question 5. Set A is given as minus 1, 1. We have to write A cross A. Let us first write Cartesian product of A and A. It is minus 1, minus 1, minus 1, 1 and 1 minus 1, 1, 1. So 4 elements. Now let us write A cross A. Minus 1, minus 1, minus 1, minus 1, minus 1, 1. So I have paired with this and this. Then with this and this. It is minus 1, 1, minus 1, minus 1, 1 and 1. Then this and this we will write. 1 minus 1 minus 1, 1 minus 1, 1. Then with the last element, we have to write ordered triplets. 1, 1 minus 1, 1, 1, 1. So this is A cross A. Question number 6. The set, the Cartesian product of A and B is given. It has 4 elements, A, X, A, Y, B, X and B, Y. Find A and B. We know that the first elements are taken from set A, second elements are taken from set B. So write all the first elements, A and B. We usually don't repeat the elements in a set. No need to write A. So it's enough if you write once. And set B, set of all second elements, X and Y. So simple. Now question number 7. Set A is 1, 2. and set B is 1, 2, 3 and 4. C set is 5, 6 and D is 5, 6, 7 and 8. Verify that A cross B intersection C is equal to A cross B intersection A cross C. Let us first find B intersection C. Common elements we have to write. Nothing is common. It is a null set. Therefore, the left hand side, which is A cross B intersection C, will be a null set. Now let us write A cross B. A has 2 elements, B has 4 elements. So A cross B will have 2 into 4, 8 elements. 1, 1, 1, 2, 1, 3, 1, 4, then 2, 1, 2, 2, 2, 3, 2, 4. We need A cross C. A has 2 elements, C has 2 elements. So 2 2s are 4 elements will be there in the Cartesian product of A and C. 1, 5, 1, 6, 2, 5, 2, 6. Now let us find the right hand side. The right hand side is A cross B intersection A cross C. We don't have any common element, so it is a null set. So LHS is equal to RHS. Therefore, A cross B intersection C is equal to A cross B intersection A cross C. So the first result is true. Now let us do the second subdivision. We have to show that A cross C is a subset of B cross D. So let us first write A cross C set. Already we wrote in the first subdivision. Let us write it again. A cross C, 1, 5, 1, 6, 2, 5 and 2, 6. Let us write B cross D. B has 4 elements, D has 4 elements. So 4 4s are 16 elements will be there in B cross D. 1, 5, 1, 6, 1, 7, 1, 8. Then 2, 5, 2, 6, 2, 7, 2, 8. 3, 5, 3, 6, 3, 7 and 3, 8. 4, 5, 4, 6, 4, 7 and 4, 8. We have written all 16 elements. Now check whether A cross C is a subset of B cross D or not. 1, 5 is there, 1, 6 is there, 2, 5, 2, 6. Yes, all elements of A cross C are there in B cross D. Therefore, A cross C is a subset of B cross D. Question 8. Let set A is equal to 1, 2 and set B is equal to 3, 4. Write the Cartesian product of A and B, which is equal to 2 2s are 4. 4 elements will be there. 1, 3, 1, 4, 2, 3 and 2, 4. How many subsets will A cross B have? List them. We have to write the set of all subsets of A cross B. We have learnt a formula in the previous lesson, in sets lesson, that if a set has m elements, number of subsets will be 2 power m. That is number of elements of the power set, if you remember. So here we have 4 elements in A cross B. Therefore, 2 power 4, 16 subsets can be written. We will write that answer. So, number of elements of A cross B is equal to 4. Therefore, number of subsets is equal to, we are using that 2 power m formula. For 4 elements, 2 power 4 subsets can be written. So, 16 subsets can be written. We have to list them. Null set is a subset of every set we know. Now we will write all singleton sets with one element. 1, 3, 1, 4, this is a subset. 2, 3 alone, this also forms a subset. Then 2, 4. Now we will go for 2, 2 elements. All subsets with 2 elements we will write. 1, 3 is one element, 1, 4 is the second element. And then 1, 3, 2, 3. And then 1, 3 and 2, 4. All combinations of 2, 2 elements I am writing. 1, 4, 2, 3. 1, 4, 2, 4. And then 2, 3, 2, 4. So I wrote all possible combinations of 2, 2 elements. Now we will go for 3, 3 elements. So I will write the first 3 elements, 1, 3, 1, 4, 2, 3. That is, I left the last element. 2, 4 I left and I wrote the remaining 3 elements. Leave this element and write the remaining 3 elements. So 1, 3, 1, 4 and 2, 4. Now leave the second element and write. Let us leave this 1, 4 and write the remaining elements. So it is 1, 3, leave that 1, 4. We have 2, 3 and 2, 4. I am leaving the first element and writing the remaining 3 elements. Okay. So I wrote all the 3, 3 element sets. Now I will go for all 4 elements. Because we know that every set is a subset of itself. So this set is also a subset. Now let us check whether we wrote all 16. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have written all subsets. So each subset is called a relation. We have written 16 subsets. Each subset is called a relation. This is what we are going to learn in the next exercise. Question 9. A and B be two sets such that n of A is equal to 3 and n of B is equal to 2. If x, 1, y, 2, z, 1 are in A cross B, find A and B, where x, y and z are distinct elements. We know that when ordered pairs are taken from the Cartesian product of two sets, the first elements, they belong to the first set A, the second elements belong to the second set B. So let me write the set of all first elements as A set, x, y and z. 3 elements. N of A is given as 3, so we got all 3 elements. Now set B. We know that set of all second elements, they form the set B. 1, 2. So we wrote 2 elements of set B. Now question number 10. The Cartesian product A cross A has 9 elements. That is, n of A cross A is 9, among which are found to be minus 1, 0 and 0, 1. So 2 elements out of 9 elements are given. Find the set A and the remaining elements of A cross A. n of A will have 3 elements. 3 3s are 9. Now let us write set A. Set A. Both the elements are taken from set A because it is A cross A. -1, 0 and 1. First element as well as the second element should be in set A. So find set A and the remaining elements of A cross A. Let us write the remaining elements. So 2 elements are given. I have to write the other elements. A set has 3 elements, -1, 0, 1. A is -1, 0, 1. Let us write the remaining elements, -1, -1. And then -1, 0 is given already. Then the third element, -1, 1. Then with 0, 0, -1, 0, 0, 0, 1 is given already. Then with 1, 1, -1, 1, 0 and 1, 1. So the remaining elements of A cross A, totally 9 elements should be there. 2 elements are given. Remaining 7 elements we had written. This is the answer. Now see page number 33. We'll do example 5. R is the set of all real numbers. What do the Cartesian product R cross R and R cross R cross R represent? Let us consider X and Y axis. We can represent all real numbers on the X axis and all real numbers on the Y axis. This is the origin, 0, 0. If I consider R cross R, any real number taken on the x-axis, another real number taken on the y-axis. So what does it represent? It represents a point in the Cartesian plane. So if I take R cross R, set of all points x, y such that x and y both are real numbers, what do I get? I get coordinates of all points in this Cartesian plane. So let us write the answer. This represents the coordinates of all points in two-dimensional space, or in Cartesian plane we can say. Okay, now what does this represent? R cross R cross R. It is a three-dimensional thing. So x, y, z, where x, y, z all are real numbers. What does this represent? It represents coordinates of all points in three-dimensional space. This chapter is very important. You have continuation in 12th standard. And you should have a basic knowledge of relations and functions. You should have a clear idea about this because we use functions in many other chapters.